Hello and welcome to my Stars Hub. Thank you so much for making time to be with us. In today's video, we are looking at quantile regression. What is quantile regression and why is quantile regression important? And what are the ways in which quantile regression can be done? I'll be using the R software. As you can see, I'm already there. Now, quantile regression is a type of regression that accepts the concept of linear regression. Quantile regression is very good over linear regression because linear regression, we are always affected by outliers. So if the data contain outliers, then it is not good to go for linear regression. However, since linear regression is also based on the conditional mean, if the response variable is skewed, then this skewedness will affect the outcome. Finally, quantile regression helps us to get a comprehensive view of the distribution of the response variable. For example, if I am looking at the the income distribution of a company, what linear regression would have done is to determine the average salary of the company. However, quantile regression will help us to know what is happening at those at the lower level and then those at the higher level. That is, we are looking at those who are least paid and those who are highly paid. Quantile regression will help us to have a comprehensive view of the whole income distribution of the company. So that is why quantile regression is very, very important over normal regression or linear regression. Again, unlike linear regression, which is based on the conditional mean as I've explained earlier, quantile regression is based on the conditional contours of response variable to given values of the covariates. I wouldn't like to bore you much with the theory since you can easily read them somewhere. Okay, so quantile regression, and I am looking at it in a way that has not been done before. I am looking at how to run quantile regression in R in three good ways. Yes, I am saying we are going to look at three ways of running quantile regression in R. Okay, so the first way is uh, the using the unique quantile package. What is this? This is for distributions where the response varies between 0 and 1. Okay, so we are looking at data set like the exchange rate or data set like any data set that is where the response varies between 0 and 1. Then you will have to go for the unique quantile package. Okay, now so we'll be doing the unique quantile package as our first way of running quantile regression in R. Okay, so you will need a package, the unique quantile. I've already installed it, so I only call the library and then I'm good to go. Now I also need data, and likely I have some data which I obtained from the unique quantile package. This data is the water data. Okay, so here I'll just run you by the head of the data so that you see the first 5 rows of each variable. So we have 5. This is the response variable. These are the covariates 1, 2, 3, 4. Okay, very good. So now I may not need to run them in the X1, I mean code them the way I did, but for the third way by which I want to run my quantile regression, this may be necessary for me. So I'll just call the values or the variable. So I'm just calling them. Okay, so like I was saying, the unique quantile package is for distributions where the response variable is between 0 and 1, and then they include what we have here. I will soon take you through. Let me run you the to get the output for the yes. So I was saying that the unique quantile package work for distributions where the response varies between 0 and 1. Distributions includes the unit Weibull, the Kumara-Swamy, unit logistic, unit Bimbe-Sanders, log, external, exponential, geometric. We also have the unit chain. The unit generalized have normal E. Unit generalized have normal X. We have the unit compass. We have the Johnson XB. We have the unit XIM. Then we have the arcsec hyperbolic Weibull. Then we have the unit compact. So these are distributions. There are many others. We have the Versec and many others that you can also look at. But they are the few ones that are currently available in the unique country package. Okay, so I am just running you by the first way of running quantile regression in R, which is the unique country. My array is quite slow. That is why the output is yet to come. So you look at it. So I have here I family, then I list all the distributions in this particular family. So my output is ready. Okay, so for each distribution, we have the intercept, we have the first covariate, second covariate, then we have the third and fourth covariate in that particular order. So you can see them here neatly done for you. Okay, so if we are looking at which of these 13 distributions offer a good fit to our data set, then we will have to go for the model selection criteria. So that is here. I will just run you by it. Okay, just run you by it again. Think that, oh, it's in here. Yes, so it's here. Okay, so you can see that among the 13 distributions, the unit logistic offer best fit because it has least value of minus 2 log likelihood of minus 8443.029, followed by the AIC BIC. Then we have the Johnson SB that follow closely, and the least distribution that is working for this data is the unit Gumbel distribution. So you see, you can say that I'm almost done with my thesis. This was be a thesis. Okay, very good. Now, if I want to get the estimate, standard error, p-values for each of my distribution, what happened? Yeah, so I'll use the summary option. Okay, so if I do this, then I'm going to look for the first distribution, and then you can see my first distributions here is the unit Weibull. Okay, so I'll get the summaries for the unit Weibull. I'll just run you by it. Yes, so the output is ready. I'll just scroll up here. You see, so you see we have for the unit Weibull. Okay, very good. So for this, I have the intercept, I have the estimates, standard z values, and p value. So you can see that all these covariates are significant at the 5% significant level, except this one, which has a p-value of 0.0556. Okay, yes, so that is how you get the estimate for each of the distributions. So if I go and I do this, then I'll get for the second distribution, which is the Kumara-Swamy distribution. So if I go up here, you see that I have my summary for Kumara-Swamy. Also, you have the estimates. The estimates are here. Let me just, these are the standard errors. These are the p-values. Again, for the Kumara-Swamy, all parameters are significant except here rather is this fourth covariate that is not significant. Okay, so I could just go around, or if I simply want, I'll just highlight all of them and I'll get the summaries for all 13 distributions. You can see them here. We have the unit Gumbel, that's the last one. Then we have the arcsecond hyperbolic Weibull. Okay, yeah, so this is how you can get your estimate. Okay, very good. Yes, so like I was saying, if you want to visualize, that is, you still want to examine the residuals to see which of these distributions offer a good fit to the data. Yes, so we could have some PP plots of the randomized residuals of the distribution. Okay, yes, so I'll run you by it. So what I did just to give you the randomized quantile residuals plot of the one of the distributions. So you can see here it is for the unit x listen. So you can see the distribution of a perfect fit to the data as the residuals cluster around the 45 degrees line, indicating that the residuals follow the normal distribution. Okay, very good. So the first one is that I've taken you through the uniquantric package, how to run it, how to obtain the estimate, how to obtain the model selection criteria, and then how to obtain the estimate, standard error, and p-value for each of the 13 distributions. Very good. So that is the uniquantric package, how to run quantile regression with the uniquantric package. If you have any queries, please put them in the comment section and I'll respond to all of them. If you are also new to our channel, please remember to subscribe and hit the subscription, the like button, so that anytime we have new content, you'll be notified. We'll continue with quantile regression. Like I said, we are going to look at 3 ways of running quantile regression in R. Yeah, so the second way of running quantile regression is the quantric package. Yes, the quantric package. Now, what is the difference between the uniquantric and then the quantric package? Like I indicated earlier, the uniquantric is distributions that are limited to the interval of 0 to 1. Okay, so for response variable where the is between 0 and 1, like exchange rate and many other examples that fall under that particular example. Okay, yeah, so the second one is the quantric package. In the quantric package, we do not assume a particular parametric distribution. Okay, this estimate the parameters directly from the data set. Okay, so I have quantric package already installed, so I'll just run you or recall it to the library. Okay, so now if I want to run just ordinary linear regression with my data set in the quantric package, what happens? So this is the code. So I will just run you through it and then I will get the summary. Okay, so we are now in the quantric package. The second way of running quantile regression in R. Yes, so you see, if I want the ordinary linear regression for my data, then I get it. Okay, yes, so the minimum value is this, the first quartile is this, the median is the third quartile is this, and the maximum value, I'm talking about the response variable. Okay, very good. And then when I come to the estimate, I have the estimate standard error p value and then z values. I mean here is t values instead. Okay, so if I want to run ordinary linear regression in the quantric package, this is what I'm going to get. Yes, so now if I also want to run the quantile regression, yes, I want to run it at, let's say, 25th quantile, 50th quantile, 75th quantile, what happened? Okay, yes, so if I want to perform quantile regression with the quantric package with the given quantile, so here I'm looking at the 25th quantile. Okay, so I'll run you by this and then I'll get the output for the 25th quantile. Okay, so you see it here. We have the tau here actually refers to the quantile. So if you see tau 0.25, I'm looking at the 25th quantile. Okay, 0.5, that means I'm looking at the median. Okay, after data set, I want to look at the middle portion of the data. then I'll run you the 50th quantile or the median. Okay, very good. So this is the output for the 25th quantile. If I want the 75th quantile, then I will use this. Remember, I'm still using my water data. Yes, so you can see tau is 0.7, but 75th quantile, this is what I have. These are the estimate, standard error, t values, and p values. They are all significant at the 5% significance level. Okay, like I said, under the quantic package, we don't assume a parametric distribution. That is why I'm not mentioning any distribution like unit Weibull, Kumara-Swamy. No, we we determine the estimate directly from the data. Okay, that is what the quantic package does. Okay, you can equally plot your summaries. Okay, so if I run you through this, okay, so I expect to have my output here. My output should come. I don't know why it's delaying. Okay, output should come. I'm rather compounding it, it will delay me. So as we still move around, when it shows up here, I will let you know. Yeah. So I've taken you through the first two ways of running quantile regression in R. The first way is using the unique quantic package, and then the second way is using the quantic package. Okay, where we estimate the parameters directly from the data rather than assume any parametric distribution as the baseline distribution. Okay, so the third way of doing quantile regression is with this. Okay, so like you saw that at the beginning, I told you that the way I am coding the data this way is for my third way of random and quantile regression. So I will take you down there, take you down here. Okay, yeah, so here we've looked at the unit variable already. So now the third way of running quantile regression is using what we have here. So if here you define the likelihood function, then you define your PDF, and then you get your initial values, and then be able to estimate. Yes, so I am looking at what quantile? I'm looking at the 50th quantile. So the quantile is here. Okay, yeah, so if I want the 10th quantile, I'll just replace 0.5 with 0.1. If I need the 25th quantile, like I did earlier, here will be 0.25, 75th quantile in that particular order. So I'll run you through it, and then you will get the output. Yeah, so the output is what we are waiting for. My plot is here to show up. I hope that, oh, okay, so my unit variable output is here. Okay, so here we have the estimate of the standard error of the Z values. Take note over here, Z values, we have P value. So for the unit variable, all parameters are significant at the 5% significance level. Okay, and you see that the negative log likelihood value here is minus 7593. Yeah, so maybe if I go back and then I compare it with the uniquantric, what we got, I will see. I'm trying to go back to where I extracted the estimate for each distribution. The unit variable was the first distribution that I looked at. Yes. So very good. We are about to get there. Okay, so these are the parameters for it. Oh no, this is the Kumara-Swamy. Okay, yes, the unit variable. So you see, look at the values that we have here. Look at these values very well. When I go, see, we have the intercept is -6. The first covariance is 11.82. Then the second one is 0.002. Take note of these values. When I go back, I'll show you. But I was just looking at the negative log likelihood. that is here. You need to see here, see what we have here. Okay, for the unicontric. And then when we went to the third way of running it, I think it reduced a bit. Yes, it gave us minus 7593. Okay, so that is it. So these are the three ways of running quantile regression in R. We said you can use the unicontric package, you can use the contric package, and then you look at where you have to determine the likelihood function of your distribution, and then you combine it with that of the PDF, and then you suggest some initial values, and then be able to obtain the estimate. Yes, even here, we'll be able to visualize. Okay, so I just did for the median, that is the 50th quantile. Okay, I mean, they're talking about it, the third way of running quantile regression. So if I change this to 75th and I run, my output will give me for the 75th, not the 15th. So I could do this, and then finally I will be able to, yeah, so you see here at the 75th quantile, the -2 log likelihood is -7724. Okay, if I reduce it to 5 and I run it to, I'm waiting for the output. Yes, so here output have reduced again to -74341. Okay, so thank you for passing through. If you have questions, queries, please put them in the comment section. Remember to subscribe so that anytime we run a new video, you'll be notified. Thank you so much, and see you in the next video. Bye.